19. A ladder 25 foot long is leaning against the wall of a house. The base is pulled away from the wall at a rate of 2 feet per second. So we get us a nice little picture here. This is the ladder. It's 25 feet long. We're given, well, let's go ahead and label this as X and Y. We're talking about, like a traditional Cartesian coordinate system, so X and Y. We're given that it's being pulled away in this direction with a rate of 2 feet per second. That's a velocity, which is dx dt, and that's 2 feet per second. We want to know what is the velocity of the top. So we're going to assume it's going down, right? Because if we're pulling the ladder this way, that's going to be lowering it, so it's going to be going down. But that's dy dt, the velocity in the y direction, when the base of the ladder is, or when the ladder is 7 feet away from the wall. So when x equals 7, and we know dx dt equals 2, we want to find dy dx. So we need some relationship between x and y, something that I can differentiate implicitly and get some equation. Well, I know that x squared plus y squared equals, in this case, since this is a Pythagorean right triangle, x squared plus y squared equals 25 squared. So let's go ahead and differentiate. We get 2x dx dt plus 2y dy dt equals 0, right? Remember, these are with respect to t, so we're going to do it just like we normally do, but using the chain rule, we're going to have to differentiate the x and the y. So since we're looking for dy dx, let's go ahead and move the dx dt over to the other side, and then we can divide by 2y. This is going to give me dy dt equals negative x over y dx dt. Now we're going to use this form for the next 3 parts of the problem. So dy dt equals negative x over y, negative 7 over, we don't have y. Well, how do we find y? If we know x and we know 25, can we not use the Pythagorean identity? We're going to go back to x squared plus y squared equals 25 squared. But I know x is 7, so x squared plus y squared equals 625. Y squared equals 625 minus 49, which is 576. And if we take the square root of 576, we get plus or minus 24. Now, since we're talking about in the positive y direction, we know that y is going to be positive 24. So 24. Now remember, this is coming down, but that's the velocity that's going down, right? This is still in the positive y direction. So any value of y will always be positive. And then we're going to multiply by dx dt, which is 2. So that gives us negative 14 over 24, which is negative 7/12, and we need to put our units feet per second. Well, I had to circle that part. Okay. Now, what if we change the 7 to 20? I don't know why that still says 7. Let's see. 20 feet. Nothing changes, right? I still know that dy dt is equal to negative x over y dx dt. But the only thing that changed here was my 20 and 25, right? I need to find what y is. So 20 squared plus y squared equals 25 squared. So 400 plus y squared equals 625. Therefore, y squared equals 225. Y equals 15. So I know x equals 20, y equals 15, dx dt equals 2. So dy dt equals negative x over y times 2. So this gives us negative 40 over 15, which they're both divisible by 5. We get negative 8/3 feet per second. And notice, just like the previous one, this was negative, which makes sense because we knew that that velocity would have to be going in the negative direction, right? Negative 8/3 feet per second. All right, what about if the base is 24 feet from the wall? Nothing is changing here. This is 24. This is 25. This is y. We still know that dy dx equals negative x over y dx dt. Now we need to say 24 squared plus y squared equals 25 squared. So we know that 24 squared was 576 plus y squared equals 625. So we get y squared equals 49, y equals plus or minus 7. But once again, it's in the positive direction, so y equals 7. So x equals 24, y equals 7, dx dt equals 2. So dy dx equals negative x over y times 2, which is going to give us negative 48 over 7 feet per second. Now, the next problem says to consider the triangle formed by the side of the house, the ladder, and the ground. Okay. Find the rate at which the area of the triangle is changing when the base, x is 20 feet from the wall. Well, we don't know, but the ladder is still 25 feet. So we know we can figure this out. X squared plus y squared equals 25 squared, but that's 20 squared is 400 plus y squared equals 625. Y squared equals 225. We already know this because we've already done it. Plus or minus 15, so y equals 15. Now, here's the issue. This asks for the rate at which the area of the triangle is changing. Well, we know that area equals 1/2 base times height, right? Well, what's the base? Ignore that this is 20 and 15 for now. Just looking at this normally, what's the base and what's the height? Well, that's just a equals 1/2. Base is x, height is y. So now we can differentiate this. dA dt equals 1/2 times the derivative of, the derivative of the first, which is dx dt times y, plus first times the derivative of the second. Right? Product rule, x times y, both respect to t. So here's what we have to do to figure out dx. So we need to know dx dt, we need to know y, we need to know x, we need to know dy dt. Well, for sure we know dx dt, we're given it as 2. We know x equals, in this problem, we were given that x equals 20. We were also given, because of the Pythagorean theorem, that y equals 15. What we're not given is dy dt. Well, how do you find dy dt? Well, we've already done that. When we're 20 feet away, dy dt was given by negative 8/3 feet per second. So we know that dy dt equals negative 8/3. Now, if we needed to figure that out, well, we would just do it the way we did it, right? We would relate the x's and y's using the Pythagorean theorem and figure out what dy dt is. But since we've already done it, we don't have to do it for this part of the problem. Now all we have to do is just plug everything in. 1/2 times dx dt, which is 2, times y, which is 15, plus x, which is 20, times dy dt, which is negative 8/3. So we wind up with 1/2 times 30 plus negative 160 over 3. Well, we need a common denominator, which is 3. So this is equal to 1/2 times 90 over 3, right? We multiply times 3 times 3. Minus 160 over 3 equals negative 70 over 3. You've got the 1/2 out front. So 2 will go into 70, 35. So negative 35 over 3. And this is an area, so feet squared per second. Negative 35 thirds feet squared per second. That means the area is actually decreasing over time, which makes sense because what happens when it gets to the bottom? You've got an area of 0, right? Because it's going to collapse in on itself. Now, the last part of this problem is arguably the most challenging. Find the rate at which the angle between the ladder and the wall is changing. So here we're talking about between the ladder and the wall. We're going to call that theta. This is x, this is y, this is 25. So we know that x equals 20. We know that y equals what? 15, right? Because we already calculated it here. This is still 20 feet, so y is still 15. We know dx dt is 2. We know that dy dt is negative 8/3, right? We calculated all this up to this point. So any of that we need, we have. But the thing is, we need to know about theta. Is there some relationship between theta, x, and y? Well, since x and y represent opposite and adjacent, I know that tan theta equals opposite over adjacent. So I can differentiate this. So the differential or the derivative of tangent theta is secant squared theta. But remember, this is not t, right? We're differentiating with respect to time. So we have to tack on that d theta dt. And that's what we want, the rate at which the angle is changing, d theta dt. So that's going to be equal to, now we do low, d high, minus high, d low, over low, low. Now, we need to get rid of this secant squared because we want the d theta dt by itself. So I'm going to divide by secant squared theta, which is just putting it on the bottom of the fraction. And now I have that d theta dt equals y dx dt minus x dy dt all over secant squared theta y squared. Now I've got y, I've got dx dt, I've got x, I've got dy dt, I've got y squared because I know y. What I don't have is secant squared theta. Or do I? Well, secant squared theta is the reciprocal of cosine squared theta, right? So let's say, well, what is cosine theta? Cosine theta is adjacent over hypotenuse, so y over 25. But I know that y is 15, which is just 3/5. Well, if I flip that, I know that secant theta is the reciprocal 5/3. And that means that secant squared theta is 25 over 9. All right, so let's go ahead and multiply this out. Y is 15, dx dt is 2, minus x, which is 20, dy dt, which is negative 8/3, all over secant squared, which is 25 over 9, times y squared, which is 15 squared, or 225. So in this case, we need to multiply. Well, let's go ahead and multiply this out. So we're going to get 30 plus 160 over 3 over, let's see, 3 will go into that 3 times, and that'll be 75. So we've got 25 times 75 all over 3. 25 times 75 is 1875 divided by 3. So we're going to multiply everything times 3 because that's the common denominator. So multiply this by 3, multiply this by 3. So we get 90 plus 160 all over 1875. So this is 90 plus 60 is 250 over 1875. Well, right away I can see they're both divisible by 5. So let's do 250 divided by 5 is 50 over 1875 divided by 5, which is 375. Still divisible by 5, so 50 divided by 5 is 10 over 375 divided by 5, 75. Still divided by 5, so 5 into 10 is 2. 5 into 75 is 15. We get 2/15. And this, since we're talking about rate at which angle is changing, we're talking about radians per second. So if you have any questions about 19, make sure and shoot me a remind or ask me a question in class. I'm going to jump on and go straight into 20. An airplane flying with an altitude of 6 miles passes directly over a radio antenna. So we have a radio antenna right here. All right, so airplane flying at an altitude of 6 miles. So say it's flying like this. And we know that this height above this antenna, this is 6 miles. Now, I'm going to go ahead and, I've got me a little, that's the worst plane ever. It looks more like a fly. Anyway, 6 miles up, flying out. So when the airplane is 10 miles away, okay, so it's 10 miles away, the radar detects that the distance from when the airplane is 10 miles away, the radar detects that the distance from the plane to the base of the antenna is changing at a rate of 260 miles per hour. So we've got a little thing. So this, we're going to call it S because it's a distance. The distance is changing at a rate of 260 miles per hour. Okay. Well, this makes us a nice little right triangle, right? We still have X, we've got Y, and we've got S. So in this case, we know that X squared plus Y squared equals S squared. So we can go ahead and differentiate 2x dx dt plus 2y dy dt equals, guess what? 2s ds dt. Now remember, we're not using any values, even though we know that this is 6 miles. We're not using that information because we need the relationship between x, y, and s. Okay? So, when we do this, what do we know? We know that this y value is not changing, right? There's no increase or decrease in our velocity up or down. That means that dy dt, that's just 0. So that can go away. So I'm just left with 2x dx dt equals 2s ds dt. Or, since we're looking for the speed of the plane, that's the velocity along the x component. That's the dx dt. So let's divide by 2x. We get that dx dt equals s over x ds dt. So in this case, I need to figure out what all these values are. So it gives us that the airplane is 10 miles away. So we're not talking about we're talking about S equals 10 here, because that's how far it is from the base of the antenna. So if that's 10, this is 6, we should be able to figure out that x squared plus 6 squared equals 10 squared, or x squared plus 36 equals 100, x squared equals 64, x equals plus or minus 8. Once again, since we're talking about a Cartesian coordinate system, the x value is in the positive direction, so x is 8. S is 10, ds dt is 260, therefore dx dt equals s divided by x times 260. So that's going to give us, let's see, 2600 divided by 8. If we put that in our calculator, 2600 divided by 8, sure enough gives us 325 miles per hour. There's our final answer. So, if you have any questions about 20, which is a much quicker problem than 19, make sure you shoot me a reminder or ask a question in class.